the applet, and then we're gonna need this.
Ba-dum-bum, ba-dum-ba-dum-bum.
Is everyone pulled up to the?
Not quite yet, but you guys can get started if you want.
The first one is.
Oh, by the way, Ricky, do you have the teacher's email? Do you think you could?
I do. Do you want me to send it to you?
Yeah, that'd be great.
Sure.
Yeah, you guys should probably get started without me. I still have to turn my computer on.
I have no idea what we're doing. If it's new material, I have no idea. So far, the first three, I don't even know what they're talking about.
Yeah.
So.
Is that the dog?
Yeah, my dog.
Sounds like it's crazy.
I don't know. Well, it's because there's people in the front yard. Hold on. Hey, knock it off.
Aren't her parents in Hawaii and she happened to be in charge of the dogs?
Pretty much.
Oh.
Sorry. One of them is a puppy, so he doesn't really understand things yet. He's little.
No problem.
He's a new little dog then?
Yeah, he's only like 6 months old. I mean, we've had him for a while, but
it sounds like a lot of fun.
Yeah, he's just little. He's a little guy.
6 months old and he's still little?
He's a Shih Tzu, so he's not going to get that big.
Shih Tzus are little Shih Tzus, if you know what I mean. Thought somebody might have thought.
Hey, Niall, are you going to conference?
Yeah, I'm actually singing in the priesthood session.
So you have the priesthood session, and what was the other one?
What do you mean?
Like, what sessions are you going to?
I'm in Provo on Saturday up until the priesthood session, and then Sunday, hopefully, I'll be able to catch a train right in.
Sweet. I'm in this Facebook group with like 10,000 seminary teachers, and somebody posted yesterday, so I don't know how much clout this has, but she said she has a son that's serving a mission in one of the Utah missions, and that President Oaks came to their sacrament meeting and supposedly said that it's going to be a historic conference and you won't want to miss it. And something about how not only are we getting 2 new apostles, but there's going to be some policy and program changes.
Oh, wow. I hope
so. Maybe it'll be exciting.
Yeah. A little bit. Change is scary, but okay.
Yeah. I don't know. We'll see.
Well, like, because they say stuff like this and not that I want this to happen. I don't, but like stuff like allowing gays to be sealed in the temple or something like that. Stuff like that that's like essential to doctrine, you know?
Yeah.
I keep thinking they're going to say like big changes to that, but it never happens. And so I'm like,
no, I don't think they'll change that. But one thing they could do is they could say like you have to be married civilly before you can get married in the temple, or they could change the age. They could change that women serve for 2 years. Who knows?
That would be cool. Not gonna lie.
In Europe, you get married civilly first. That's like the law.
Right. And or my husband, only because he's gospel doctrine teacher, said maybe finally the rumor that we won't have Sunday school anymore will be true.
Whatever. All right, I'm ready to go.
All right, let's go.
So given the linear regression equation y equals 2 plus 1.5x, what is the y-intercept? How does that formula work? I can't remember.
I have no idea.
Okay, let us.
Equals mx plus b.
Yeah, but which one would be the b? So the 2 would be the b, right? And then what you would want to do is the 1.5 divided by 2. Is that what you're saying?
I think so, but I'm not.
That
I'm
makes sense. So 1.5 divided by 2. Where's my phone? Let's see what that would be. Sorry. Wouldn't it be 3/4? So 0.75?
That's what I got.
Okay. All right. Give the linear regression. Wait. What is the y-intercept? So what is the slope? Wouldn't it be the same thing? Or no? No, the slope would be 0.75. But what would be the y-intercept? Because the slope is always between -1 and 1.
Right.
Whereas the y-intercept, I feel like it'd be the same thing. Shoot. Let's check. Does anybody have the book open?
No, I'm going to open it right now, though.
Yeah, that's what I'm doing right now. Ba-da-ba-dum. Ba-da-ba-dee-da-ba-dum-ba-dum. Ba-da-bum. Ba-da-ba-dum. Ba-da-ba-dum-ba-ba-dum-ba-dum. Ba-da-ba-dum-bum-bum. Ba-da-ba-dum. Okay. I don't care about super croc. What the heck is super croc? Gross. This is not helping at all.
I'm looking for it here. Regression equation. Is that what we're looking for?
Yes, but we're looking for the y-intercept and we're looking for the slope.
Well, this says.
So y-intercept of the line. Wait. So the BO is the y-intercept and the B1 is the slope. So the 2 would be the y-intercept and the 1.5 would be the slope. So I was wrong about the slope having to be between -1 and 1.
So 3 is 2.0.
So yeah, 3 would be 2. I guess we could put in 2.0. And 4 would be 1.5. That would make sense because it's rise over 1. So 1.5 would literally be like, for example, 3 over 2. So go up 3 over 2, up 3 over 2. That would make sense. Given the linear regression equation, y equals -3 plus 0.25x, what is the predicted value of y when x is 16? So y would be 1, wouldn't it?
5 would be 1. Is that what you
So 1/4 of 16 would be 4 plus -3 is 1. For the next 7 questions, use the data file math self-efficacy. Be sure to use the confidence data for the explanatory variable and score. I take it. Are we using the categorical, or which one are we using?
No, I think it's still just the t-test for linear regression, isn't it?
I wouldn't know. Let's check. What does it say in Excel?
Because it says use the confidence data for explanation.
It's wanting us to use the quantitative inferential procedures, so I guess
Right.
we would use the t-test. It would only make sense.
So what are we putting in for the, what does it say here? Confidence data for what? Oh,
This math self-efficacy one is now downloading. It's not going to make us use a 2 sample, is it?
I don't think so.
Okay, good, because that's where I have all our information from.
Yeah. Okay, let's see. So this one, it mixes it up. So it has you put the second column of data in the first.
Well, what are we going for? We're going for score and confidence rating mean, right? Those two?
Yeah. So it says to make sure you use the, just a second, I'm trying to erase this old stuff in here. It says, be sure to use the confidence data for the explanatory variable and the score for the response. So when you look at the data, the confidence is actually the second. You know what I mean? They have you do it the other way.
My Excel is freezing up on me.
I'm putting it in right now. I'm just not sure I'm going to know how to read it, but we'll see. We'll do our best here.
Why are you freezing up on me, stupid? Oh, this is so annoying. Like, this is super annoying.
Okay, I have it in there. But I didn't, of the 3 data shapes introduced in the reading, which shape best describes this data? Hot dog, hamburger, or banana?
I think it's hot dog.
I think it's hot dog. I don't know.
So funny.
One sec. So, where did you put this into?
I put it into the quantitative inference procedures under linear regression.
Okay.
But you have to put the explanatory variable is the confidence data column, and then the other one is the score.
What the fuck? I don't know. My Excel is really acting up. It's been really annoying these last couple of days.
Because you need to use it.
So
I don't know what that looks like. I guess a hot dog.
No, I would say hot dog.
Oh my gosh. You know what? Screw it. I'll trust you guys. Not like I did before, but still. This is annoying. So it's straight, it's not curved, it's not like it's not all bunched together either.
It is kind of all bunched together.
Well, then I would probably call that hamburger,
but well, it's long though. It's long.
Okay, then we'll keep hot dog then. Because when it's all in a cluster, we would call that hamburger, and then when it's curved, it's banana, and when it's just straight, it's hot dog. So question 7, based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? If hot dog, then I would say that it's appropriate.
Yeah, I would say it's the first one.
Which, by the way, because of the Moscow data or whatever,
yeah,
that I had to say that it was not normal and that we couldn't use it or something like that. Like
no, she said we can use it, but it's not normal. But we can still use it because our sample size was 30.
Oh, okay. Well, then I'll have to change up my answer. Cool. How many observations are in the data? observations meaning each individual unit, right?
I would think. Or is it paired? No, there's one for each one, right?
Yes.
So what's that going to be?
Well, let's read the comments here. So Shane Goodwin and other researchers studied factors that affect a student's confidence interval on a multiple choice mathematics exam. A group of n equals 139. I would say that would be our number. Like each person would be an observation. No?
Yeah, I would think so.
An exam consists of 30 multiple choice confidence rating. What is this rating mean? Oh, how well it did. Okay. Yeah, so I would say 139 because each score and confidence rating mean is per one person.
Yeah, that's what I've heard.
Okay.
So you're saying number 8 is 139?
Yeah, I think it would be the sample size.
And I think 9 is 18.690.
18.690. Okay.
Okay.
What would be the slope?
12.695.
What was that?
12.695.
Okay. And then what is the predicted value of y when x is equal to 4? Well, would we have to create a formula for that, or?
I got 69.469. I don't really know.
69.
I put the formula in Excel, but I got it really easily, so I feel like.
Okay.
And
then, are we ready to go on to 12?
Yeah, I don't know 12.
The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Hint, because there's a positive correlation, we can use the largest x value to find the largest predicted value of y. So if you can use a scatter plot and find out what the largest x value is, then you can also find out. Okay, so it's basically the biggest point on the scatter plot, if you know what I mean. Like,
yeah, like the top one?
Yes, I believe so. Let's see what my thing says here. So my guess is it would be one of these that says that they got 100. Oh, shoot. So my thing says here that they got 100 on the x-axis, and then they got a 5.53 on the y-axis.
Mm-hmm.
That would be the largest one.
So 5.53?
What is the maximum predicted value of y for these values of x? Yes, I believe so. And if it's not 5.53, then it would be let's go here. 5.93.
Okay.
Oh no, 5.97. But the person really got in 83.3. So I think it's 5.53 is what it's at.
So I just submitted it because I did the last 3 questions and that's wrong. That's the only one we got wrong.
So it might be 5.97.
I'm going to take that.
But the hint makes it that hint doesn't make any sense. How many explanatory independent variables?
You can use the largest x value to find the largest predicted value of y.
Well, that's what I'm saying. If the largest value of x is 100, then and the largest y value for that is 5.53, then that one. You know what I mean?
Mm-hmm.
But the
But
largest,
there is that 5.93, which is, I don't
I
know.
think that would be it.
I have no idea.
So I could submit it as 5.97 and see how that works, and then
Okay.
if that doesn't, then somebody can submit it at 5.93. But let's continue. So the next one, is it 2?
Are we on 13?
Yeah, 13.
It's 1.
How do you explain it? Oh no, never mind. There's just one. I thought it was just how many different sets of data. How many response-dependent variables are present? Just one, right?
Sorry, yeah, it's just 1.
Okay.
14. So 13 is 1 and 14 is 1?
Yeah. Question 15. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats produced for quality control and planning purposes. The measurements they can collect include hat size, circumference of hat, and lengths of major and minor axes. Meaning, the company wants to predict the size of hat given the circumference. What is the response variable?
The first.
The size of the hat, right?
Yeah.
Yeah, the first one.
Because it is being used to predict circumference. Okay.
So it's the first one or the third one?
The third one. All right, I'm gonna see what I get with 5.97, and
Okay.
let's see here. Yeah, I got that one too.
You got it wrong?
Yeah, but I got question 15 wrong as well. So it's not 5.97, and it's not the third one. What did you put, Allie?
15 is the first one.
Oh, yeah. Well, let me redo this really fast then.
But we still got number 12 wrong?
Yep. Correctamundo.
So did you put 5.3 or did you put?
I put 5.97. You could try 5.93 though.
I want one more try.
I can do it. I have 2 tries. I'm just entering in this other stuff really quick because I just wrote it down on a paper. I'm almost done. 7. Okay, so we're going to say 4.93. I mean 5.93.
Yes.
Okay, let's see here. Okay. Nope. I got it wrong too.
Okay, this is really dumb. Well, obviously we didn't take the hint right, so we'll have to try again. 4, 6, 9. Well, wait, what did you? Can you guys look at your scatter plot, and then if you hover your mouse over, if you zoom in and hover your mouse over the whatchamacallit, it'll come up as a point. Can you pick? Because I think I might have my data wrong.
Oh, there's one that says it's 6.
There is one that says it's 6.
Yeah, but okay, so don't laugh at me. X is first, right? It's X and then comma the Y.
Yes.
Okay, so there's one that says series 1.6 and then it says 6 comma 96.7.
Wait. So the highest X value is 6. Am I correct?
That's what it says.
And then then that the coordinating y point for that is, what was that again?
96.7.
All right, I'm gonna go ahead and try that. 96.7. I think we have it wrong. I think because I didn't have my data incorrectly. I'm sorry about that.
Well, they're so close together now that I saw the same thing you did, but when I just moved my mouse, I'm like, oh, there's another one right there.
Yeah. Well, that's why you have to zoom in.
Yeah.
So 96.7, and then I'm trying to think here, and that's the largest X value, you say?
That's what it looks like to me.
Okay, and there's nothing up above, like there's not another point above that one?
I don't think so. I just totally screwed my screen up. So just let me see here.
Yeah, just zoom in a little bit more.
Oh crap, how do I zoom in? It's not letting me zoom. Oh, here we go.
Oh.
Zoom. What am I doing wrong here?
Well, it should be on the side of the page on the bottom right-hand corner.
Oh, right there, I see it.
Yeah.
Well, what's weird is there's several at the top that are they're right on that top line that are 5.53, 5.2, 4.9, and then if you drop down just a little bit, but it's further over, it says 6. And the one next to it says 5.93, and the one next to that says 5.8.
Right, but so what the hint says is that we use the largest X value to find the largest predicted value of Y.
Right. So X is the one that's horizontal or vertical?
X is horizontal.
Okay, yep, that is the farthest horizontal.
So 6, and then the score was 80, or
was 96.7.
6.7. All right, I'm gonna submit that and see what it says. I still got it wrong. Wait, what?
Oh man.
No. Yeah, I did. But what the fetch? I got another one wrong. That's so stupid.
I don't understand what they're
What was
asking.
10 was
I
12.
think that hint is trying to confuse us.
Well, I guess you could try the largest value of Y, which would be 100, technically.
Okay, I'll try it.
But what was 10 again?
10 is 12.695.
So stupid. All right. Well, let me know what happens when you...
So you think I should put 100?
Yeah. That's my guess.
Okay. I can do it really quick here. Next week we only have one more lesson and then we're studying for the test and then we're almost done.
Good.
Oh.
Let's be done.
So what should we put for 12? 100?
I'm going to put 100 and see what we get here. I'm just entering it all back in on the second because it's my second attempt. And if we get it wrong, then I have no idea what it is. All right, I'm submitting.
Sweet.
Still got it wrong. So I don't know, folks.
All right. What's the question again?
The question is, the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of Y for these values of X? Hint, because there's a positive correlation, we can use the largest X value to find the largest predicted value of Y.
So we want the largest predicted value of Y, right?
Yes.
So, and this is from the data from the whatchamacallit, right? Or is this different data?
Oh, wait a minute. Look at this. I don't know. I could be wrong, but if I'm looking at this spreadsheet, right above the scatter plot.
Right. There's a cell that says predicted.
Yeah, and it says 94.859.
Well, then it would be that one because
I bet that's the answer.
I'm looking at the book right
I haven't submitted, so I'll put it.
and the book is saying that there should be a cell in the Excel program that says predict.
That was right.
So the answer was right there, right in front of us, and we didn't even know. All right.
Yep.
It's all good.
All right. I will talk to you guys.
Danielle, do you need us to go over anything? Danielle! Are you there? Hello.
I don't know what she's doing.
We can't hear you, Danielle.